Welcome to Think Global Education Services. Today's topic is energy and power. First, we shall discuss about potential energy or gravitational potential energy. It is written as GPE. We can write it as EP. E is a subscript P. We can represent the gravitational potential energy like that. Now, gravitational potential energy is the energy of an object by virtue of its position. For example, let's just say this is the surface of the Earth and the object is at a height h from the surface of the Earth. The object is here. Height is h. Now, this object has a mass m and it is attracted towards the Earth with the gravitational force. Now, due to the virtue of its position, it has an energy stored in it, and we can call that energy as the gravitational potential energy of the object, which is equal to mass of the object multiplied by the gravitational acceleration multiplied by h. Now, in case if the object is moving, then it has a kinetic energy. We can write that as Ek, E subscript k, which is kinetic energy. The kinetic energy of the object is equal to half m v squared. Here v is the velocity, m is the mass. Now we can equate these two. That is, let's just say the first object has a potential energy and then it falls. Then the potential energy is converted into kinetic energy. Now that is the conservation of energy. We're using conservation of energy to equate that. That is the object which is at a height h falls. So the height is changing with the time. So what we can represent that as is that mg changing height is equal to of mv squared. That is, at this position, the position h from the surface of the Earth, the object has a highest potential energy. That is the largest potential energy, and as soon as it goes down, the potential energy decreases and the kinetic energy starts to increase. So at this point, the potential energy is maximum, kinetic energy is 0 or minimum. Now, when the object starts to go, the kinetic energy increases and the potential energy starts to drop. So as the height decreases, potential energy also decreases. So that's the reason why we are writing delta h, change in height. Now here, you can rewrite this equation to derive for velocity of the object which is falling, which is equal to square root of 2 m. Now here m and m will get cancelled, so we will not get m, so 2g. Right. So what does it represent? It says that whenever an object is falling, it does not matter the mass of the object. For example, just say, now this condition is only true when we ignore air resistance and friction. So let's just say a very large ball and a very small ball. If you drop them from the same height, then they both will fall at the same time. They will they accelerate at the same time, and they will both reach the surface of the Earth at the same time. It does not matter. The mass does not matter there. So that's what we can deduce from this equation. Now we can also rewrite the equation to find out the height. That is change in height, which is equal to, again the mass and mass will get cancelled, so we will get v squared divided by 2g. Now here also mass doesn't matter. So now we have discussed about potential energy, gravitational potential energy, and kinetic energy. Now in physics, energy is related to work done. So what is work done? Work done is, let's just say you have an object here and you're pushing this object with a force. So force is represented by F, and if you push the object will move a particular distance, and this distance is delta S. Delta is the distance moved. So work done is represented by W, which is equal to force multiplied by the distance the object moved due to the force. This is the work done. And we can write power in terms of work done. Power is equal to energy transferred divided by time taken for the transfer of energy. always equal to energy transfer divided by time taken for the transfer of energy. So E divided by T. You can also write power as work done divided by time for the work to be completed. So which is equal to work done divided by time. All of these quantities are the same. And we also can write it as work done is EF delta S divided by T. That is force multiplied by the distance moved divided by the time taken for the force to move the particular object to a certain distance. Now we have discussed about power. Now we can discuss about efficiency. So when we have power, we want to discuss the efficiency of the work which we do. So that's what determines the usefulness of the work. So efficiency is nothing but useful work done divided by total energy input. So useful work done divided by total energy input. We can also write the work done as useful energy output divided by total energy input. So there are different ways for measuring efficiency and power. Again, power is nothing but energy transferred by time taken for the energy to be transferred, and work done by time, and work done is nothing but EF multiplied by the distance to which the object is moved by the force divided by time, that is power. And here kinetic energy is half mv squared and potential energy is mgh. And when we equate it, we can get the velocity with which the object will be falling from a certain height. Thank you for watching.